Hey everyone, welcome again to this section on extensive games with imperfect information. In this lecture we're going to see some practical examples. First of all, we need to remember that, and this is something that we already saw, if every information set of every player consists of a single node, then the extensive form is said to have perfect information. Otherwise, that is, if at least one player has at least one information set that consists of at least two nodes, the extensive form is said to have imperfect information. In this lecture, we're going to see examples of imperfect information. Okay, let us begin with the first example. In this example, there are three players: Alice, Bob, and Carla. Initially, Alice and Bob are in the same room, while Carla is outside. Alice moves first, choosing either a red card or a black card from a full deck, shows it to Bob, and then places it face down on the table. Here we can see in this illustration the initial situation, right? We have Alice and Bob in the same room, and then we have Carla outside this room. Now, Carla then enters the room and Bob makes a statement to her. He either says, Alice chose a red card or Alice chose a black card. Bob may be telling the truth or lying. After hearing Bob's statement, Carla must guess the color of the card Alice picked. The card is then revealed. If Carla guessed correctly, Alice and Bob each give her $1. Otherwise, Carla pays $1 to both Alice and Bob. Now, what is important here is that when we represent this situation as an extensive form game, we need to think carefully about what Carla actually knows when she makes her guess and what she doesn't. Okay, so now let us see how we can represent this situation as an extensive game form, and not only that, but also how we can assign utilities to the outcomes, thus forming a game. So here we can see this representation. Notice that this is already a game, not just a game form, because we have utilities assigned to the outcomes. Recall that the outcomes correspond to the terminal nodes in a game tree. Notice moreover how we enclose an information set with a rounded rectangle. This is something that we saw at the beginning of this section. So let us now analyze this first information set. Notice that Carla's top information set captures the situation she is in after hearing Bob say, Alice chose a black card, and also not knowing if he's telling the truth, which is the left node, or he is lying, which is the right node. Now, this information set in here, Carla's bottom information set, captures the alternative situation where she hears Bob say, Alice chose a red card, and does not know if he is lying, which corresponds to the left node, or telling the truth, which is here the right node. So the first thing that we can say here is that this game is a game with imperfect information. Why? Well, because we have at least one player, namely Carla, that has at least one information set, and in fact she has two information sets that satisfy this condition, that consists of at least two nodes. And we can see that both of these information sets, they have two nodes, right? In both situations, Carla knows something, namely what Bob tells her, but lacks information about something else, namely what Alice chose. Also pay attention, the fact that Bob knows the color of the card chosen by Alice is captured by giving Bob two information sets, each consisting of a single node. Bob's left node represents the situation he is in when he sees that Alice picked a black card, while his right node represents the situation he is in when he sees that Alice picked a red card. Finally, we can also see the utility vectors. Let us just suppose here this outcome in here. We have that Alice chose a black card, Bob decides to tell Carla the truth, and then Carla guesses the color black. So notice that in this case, Carla guessed correctly, and thus Alice and Bob each must give her $1. So at the end, Carla is going to win $2. Notice how the green color utility is Carla's utility, Carla's payoff. Then Bob must give her $1, so his utility is -1, this utility in blue. And finally, Alice's utility is also -1 because Alice gives Carla $1. Okay, let us now analyze this outcome here, this terminal node and this utility vector. In this case, Alice chooses a black card, Bob decides to lie, and then Carla here guesses the red card. So in this case, notice how Carla did not guess correctly, so she must pay $1 to both Alice and Bob. So in this case, Carla's utility is going to be -2. She pays $2. Bob's utility is $1. He earns $1 from Carla. And also Alice's utility is $1, as she also earns $1 from Carla. So we can do the same reasoning for all of the outcomes. And with this, we end the analysis of this extensive form game with imperfect information. Let us now see a second example. It states 2 candidates, Olivia and James, applied for the same job, although only one can be selected. The employer told each candidate, "Don't call me, I will call you if I want to offer you the job." He also told them that he desperately needs to fill the position, and thus, if turned down by one candidate, he will automatically make the offer to the other candidate, without revealing whether he is making a first or a recycled offer. Moreover, suppose that the employer only cares about whether the position is filled or not. Thus, the employer prefers filling the position to not filling it, but is indifferent between filling it with Olivia or with James. Now, Olivia's favorite outcome is to be hired if she was the recipient of the first call by the employer. Her second best outcome is not to be hired, and her worst outcome is to accept a recycled offer. Okay, let us define this game frame, this game tree. Notice that the first one that makes a move is the employer. The employer is the first one that executes an action. The employer decides whether to call Olivia first or James first. What is very important in this problem and in this game tree is that the employer told the candidates that if he is turned down by one candidate, he will automatically make the offer to the other candidate. This is reflected in the game tree. Let us suppose, for instance, that the employer first calls Olivia. If she says yes, then the position gets filled and we end. Now, what if Olivia rejects the first call? Well, in such case, the offer automatically goes to the other candidate. So now we go to a decision node where James must take an action. If James says yes, then the position gets filled and we end. Now, what if James says no? Well, if James says no, then we reach an outcome with no one hired, right? Because both players reject the offer. So analogously, we can see the same type of transition from James to Olivia if James says no and James was the first one that the employer called. So the important thing here in this game frame is to see and visualize this transition. So what we have right now is a game frame, right? So if we want to obtain a game, what we need to do is we need to add a ranking of the outcomes for each player. So essentially their utilities for each possible outcome. So let us begin with the employer's utilities. Remember that the employer only cares about whether the position is filled or not. So the employer prefers filling the position to not filling it, but is indifferent between filling it with Olivia or with James. So from this we can see that we can assign a utility of 1 for the employer to every outcome where one of the two candidates accepts the offer, and a utility of 0 to every other outcome. Essentially, whenever someone is hired or whenever the position is filled, the employer's utility will be 1. Otherwise, the employer's utility will be 0. Now, what about the utilities of the candidates? Well, let us begin with Olivia. Olivia's best outcome is the one where she accepts a first offer. So we assign a utility of 2 to that case. Her second best outcome is not getting the job at all, which isn't ideal, but it's still better than feeling like a backup option. So we give that a utility of 1. Finally, the worst outcome for her is accepting the offer knowing it was originally rejected by James, which will make her feel like a second choice. So we assign that situation a utility of 0. James' preferences followed the same pattern as Olivia's, but in the opposite direction. His best outcome is being offered the job first and accepting it. So we assign this a utility of 2. If he does not get hired at all, that is still better than feeling like a backup. So we give that a utility of 1. And finally, the worst outcome for him is accepting the job after Olivia rejected it, which makes him feel like the second choice. So we give that a utility of 0. With all of this in mind, we can now integrate these utility vectors. Remember that in an extensive form game, we need to assign utility vectors to the terminal nodes to all of the outcomes. So let us consider this outcome. For example, in this case, the employer first calls Olivia, she accepts the offer, so this is the best outcome for her, thus her utility is 2. The employer's utility is 1 because, as we can see, someone is hired and the position is filled. And finally, James' utility is 1 since this is his second best outcome. Okay, let us now analyze this terminal node in here. So notice that this outcome considers the case where the employer first called Olivia, she said no, so we come to this decision node, and if James says no, so if he also rejects the offer, then the employer's utility is 0 because the position is not filled, and the utilities of both James and Olivia are 1 since they are not hired. And this situation represents their second best outcome, with a utility of 1. Notice that we can do the same reasoning for all terminal nodes. Finally, it is very important to bear in mind that this is an extensive form game with imperfect information. And this is because we have at least one information set that consists of at least 2 nodes. Namely, in this game we have these 2 information sets that are enclosed within a rectangle. Notice, let us begin with Olivia's information set. She might be receiving a call either as the employer's first choice or as a second option after James has rejected the job. However, the employer does not reveal this to her. She does not know whether she is being offered the job first or if she is being offered a recycled offer. It is very important not to get confused here. Because the fact that we have a directed edge from this decision node to this decision node in here does not mean in any way that it is James who is calling Olivia and offering her the job. The job is always offered by the employer. They are the one making the calls. And the same idea applies to this directed edge, from this decision node to this one. Okay, so let us come back to Olivia's information set. We can see how her decision nodes in both cases, being first code or second code, are grouped into a single information set with two nodes. She makes her decision, yes or no, without knowing which of the two cases she is in. That is the essence of imperfect information. The same applies to James. He also has an information set with two decision nodes, one where he is the first person to be called by the employer, and one where he is being contacted only after Olivia has turned down the offer. James, just like Olivia, cannot distinguish between these two situations when making his decision, because the employer hides this information to maintain fairness or to avoid influencing their choices. So, in both cases, the players are uncertain about the history of the game when it is their turn to move. This is precisely what creates imperfect information. Very well, and with this we end this lecture on practical examples of extensive games with imperfect information.